Hi, my name is Muhammad Zahanus bin Amir, and today I will present to you my microteaching project for MAE503, and I will teach you about indefinite integral. The photo shows a nurse is taking a blood pressure of their peers. What method is used to determine the blood pressure in the aorta after 3 seconds for a normal person? By applying an indefinite integral to the rate of blood pressure, we can determine the blood pressure of the person. First out of it, so indefinite integral formula. For constant a, we have integrate a ds equal to as plus c. And secondly, for constant as to the power of n, we have integrate as to the power of n ds equal to as to the power of n plus 1 over n plus 1 plus c, where n is not equal to 0.
Alright, so for constant a, we have the formula of integrate a ds is equal to as plus c. So for a constant, it can be everything. It can accept for variables. So it can be numbers, or it can be a symbols of pi or set. Okay, here we have some example that is integrate 2 ds and we will get 2s plus c. Okay, here is plus c is a very important for us to write because c is represent of our constant. Here we have integrate 5 by ds and we will get 5 by s plus c, and integrate set 2 ds and we will get set 2 s plus c. Alright, so for constant as to the power of n, we have given a form that is integrate as to the power of n ds is equal to as to the power of n plus 1 over n plus 1 plus c, okay, where n is not equal to 0. Okay, so the c there is a very compulsory and important for you to write. Don't forget it. Okay, don't forget it. So let's do some example. We have integrate 2s squared ds. So first thing first, you have to recognize what is our a, what is our s, what is our n. So here is our a, it's a constant. Our s is s, and a power of 2 is our n. So follow the equations or the formula. We will get 2s to the power of 2 plus 1 over 2 plus 1, okay, plus c. C is a very compulsory for you to write. Then we have 2s cubed plus 3 plus c. Okay, so we will get the final answer. So next question, next example, we have 4s cubed ds. Okay, so again we have to recognize what is our a, what is our s, what is our n. So our a is 4 and our s is s, and our to the power of 3 or cubed is our n. Okay, all right, so follow the formula and you will get 4x 3 plus 1 over 3 plus 1 plus c, and then we add that numbers and we will get 4x to the power of 4 plus over 4 plus c, and then we can simplify 4 over 4, we will get 1, and then the final answer we will get x to the power of 4 plus c. That's it.
Second subtopic, that is indefinite integral for algebraic functions. We have integrate in the bracket of fx plus gs ds is equal to integrate fx ds plus integrate gx dx, we can separate the function.
Alright, so for here we have the indefinite integral for algebraic functions. Is a given formula is integrate fs plus minus gs is equal to integrate fs ds plus minus integrate gs ds is actually just a separations of integration. Separate for one function and one functions from the combined functions to separations functions. So we have integrate fs ds and integrate gs ds is a separation. So here plus minus is it depends on what signs we use in that equations overall. So here I have the example 1, that is integrate 3s squared plus 2 ds. Okay, so follow the rules, follow the formula, we separate each functions, that is integrate 3s squared ds plus integrate 2 ds, and we will get 3s cubed. Okay, as for the n, 2 is our n, right? So 2 plus 1 is 3 and 2 plus 1 is 3. So plus 2s because it's for constant a, remember, and c for our constant. It must be right and compulsory. So here we have a 3 over 3. It can be simplified. Okay, it can be simplified, and our answer, our final answer is s to the s cubed plus 2s plus c. Alright, so our next example is integrate 4s to the power of 5 plus 5s plus 3 ds. So follow the rules, separate it. Okay, integrate 4s to the power of 5 ds plus integrate 5s ds plus 3 ds. So follow the rules of integrations. The power is plus 1 and then over by power plus 1. There is n. So 4s to the power of 6 over 6 plus 5s to the power of 2 over 2 plus 3s plus c, and we can simplify actually. 4 over 6 we will get 2 over 3, right? So we can write 2s to the power of 6 over 3 plus 5s squared over 2 plus 3s plus c. Hi guys, so this is the exercises for our previous subtopic, that is indefinite integral for combinations of multiple algebraic functions. So here, okay, we have the integrate of s squared in bracket of 3s squared plus 5s plus 1 ds. Alright, so this is the question. So what is the formula that we have to use? Okay, so we have this one, right? Okay, the given formula is just including fs and gs, right? So it is actually, it can be up to many functions that we can separate. All right, so the first step is you have to simplify the form. Okay, it's quite hard for you to do, right? So we simplify, that is we expanded. Okay, we expanded 3s to the power of 4. Okay, and then we have 5s cube and s squared ds, right? All right, so and when we separate it using this formula, so we can use this plus integrate 5s cubed ds plus integrate s squared dx. So is it easier for you to write? Okay, so s to the power of 4, we get s to the power of 5 over 5 plus 5 s to the power of 3, we will get s to the power of 4 over 4 plus s squared will be x cubed over 3. Don't forget the c. Alright, so next we simplify the form. Okay, it can be so easy. Okay, just multiply to each other. Okay, and voila, you will get the answer, right? So it is easy, right? Okay, this is quite easy. So move to the next subtopic.
Thirdly, indefinite integral for functions in the form of as plus b to the power of n. So here we have the integrate of as plus b to the power of n ds is equal to as plus b to the power of n plus 1 over by a times n plus 1 plus c, where n is not equal to 1. Or we can using the substitution method to finding the indefinite integral.
Alright, so for this subtopic, indefinite integral for functions in the form of ax plus b to the power of n. Okay, there is a formula for it. Integrate as plus b to the power of n ds is equal to as plus b to the power of n plus 1 over a times n plus 1 plus c. Okay, where n is not equal to 1. Okay, so we move to our first example, we will get integrate 2 minus 3x to the power of 4 ds. Okay, and so first thing first, we have to analyze what is our a. That is, okay, 2. What is our 2? It is b. Okay, negative 3 is our a. Our s is s. And 4 is our n. That means the power. So if then we include all the informations into that formula, we will get 2 minus 3 to the power of 5 over negative 3 times 5. And if we simplify negative 3 times 5, we will get negative 15. So our final answer is negative 2 minus 3x to the power of 5 over 15 plus c. So next example is 3 over 5x minus 3 here. So here we can look, the functions is in the denominator. So what we have to do is we have to simplify or change it to the power into negative 6. So and then as well as we have to analyze what is our a. Our a is 5, our x is x, and our negative 3 is b. Okay, and negative 6 is n. So and then we put all the informations again into that in formula. We get 3 5x minus 3 to the power of negative 6 over 5 times negative 5. And then we simplify, we will get the final answer negative 3 over 25 5x minus 3 to the power of 5 plus c. Alright guys, so we turn back. Here is the exercises for us to do that is related to our subtopic, that is indefinite integral for functions in the form of as plus b to the power of n. Alright, so read the exercises. Integrate the following function with respect to x using the formula. So what is our formula? Yes. Okay, so look. Here we have 5 over 6x minus 3, but the formula is as plus b. Okay, it is not the fractions, right? But here we have the questions in fractions. So how to do it? So here I will teach you. Okay, first thing first. Okay, you see the functions. So the functions is in the denominator. We put as a functions, but not in the fraction. Okay, so how do we? Okay, we make, okay, we change the power to negative 6. So the new integrations is quite similar to our formula, right? So how to do it. Okay, so we first thing first, we have to identify what is our A. Okay, what is our A? Our A is 6. Our A is 6. So what is our B? Our B is -3. Okay, -3, not 3 only. Okay, so what is our N? Our N is -6. -6. So, okay, 5 is a constant, right? Okay, and we can just place it. Alright, so we focus on this function. So, follow this rule or this formula. Okay, so here we have, just copy the functions first, and then the power is +1, and then over A. What is our A? 6. What is our N? -6 plus 1 plus C. Okay. So, we simplify. Okay, we simplify and turn it into 6 as -3 to the power of a -5 over what is the -6 plus 1 times 6. We will get -30. Oh, we can simplify it to the form of using the uh, 5 over by -30. We will get 6, right? -1 over -1/6. -1/6. And 6/3. -5 plus C. So here, it is correct, but it is not a great answer, because the great answer is, okay, or we can write as -1 over, okay, since it is a negative, right? So the place for the negative index or our negative power is in the below, or is in the denominator. -6 minus 3 is to the power of 5 plus C. That's it. So simple, right? Okay, so move to the next subtopic. Okay. Alright, so for this subtopic, indefinite integral using substitution method with using u. Okay, and then we move to our example 1. We have integrate 3x plus 5 to the power of 5 dx. Okay, so we want using the substitution method. So let u is equal to 3x plus 5. Okay, let u will be our function. Okay, our function. So we differentiate the u. We will get u over dx over 3, and then rearrange and let the dx be alone. We will get du over 3. And then we substitute all the informations to our questions. That is, we will get integrate u to the power of 5 over 3 du. Alright, so if we integrate the u, we will get 1 over 3 u to the power of 6 over 6 plus c. So, and then we substitute back the value of c in the final answer. Okay, so we will get 3x plus 5 to the power of 6, and 3 times 6 is equal to 18 plus c. Don't forget the c. Alright guys, so this is our exercises for our subtopic indefinite integral using substitution method. So remember, when the question asks you to use the substitution method, what you have to do? So first, you have to let u, and then you have to differentiate the u. Okay, differentiate the u, and then you have to substitute u into the function. Okay, so here, what is the function that we have to let? Okay, to let u. So remember, when we want to let u, do the let u, it must be the function. So what is the function here? 3x minus 2, right? So let u, sorry, um, let u equal to 3x minus 2. Okay, and then differentiate the u. So du over ds, we will get 3. And then rearrange um rearrange and let the dx be alone. Because why? Here we have the dx alone. So let the dx be alone there. All right, so we have a du over 3 here. So what you have to do is substitute all the informations, especially the u and the dx equal to du over 3 into the given question. Okay, so here we have, okay, I will do here. So 3 over 2 u squared times du over 3. Oh, look, we have a 3 in the numerator and 3 in the denominator. Can we cancel it? Yes, we can cancel it because 3 over 3 is 1. Okay, so here we have 1 over 2 u squared du, right? Okay, so look, the u squared is in the denominator. So how to do it? You have to let the power be a negative, just like the previous subtopic. So it will be u negative 2 du. All right. So okay, I will do here. Sorry, I will do here. So it's equal to the integrate. Oh, sorry. Okay, integrate. We already make the integration. So times with u. Negative 2 plus 1 is what? Negative 2 plus 1 plus c. C, don't forget, because c is a constant. Okay, it's a compulsory for you to write. Okay, so here we have negative 1 over 2 times u to the power of negative 2 plus 1 is negative 1. So here is negative 1 plus c. Okay, so here negative 1 over 2 times 1 over negative 1, it will be negative 1 over 2. Okay, so u to the power of negative 1, it will be 1 over u, right? 1 over u plus c. Okay, and then u. Okay, the question is in the terms of x. So we must substitute the value of u into that equations, or into that the answer. Okay, so we have a negative. Okay, actually we can times it 1 over 2 in the bracket of 3x minus 2, okay, plus c. All right, so the functions power is 1, right? So the best answer for you to write is you multiply of 2 into that function. So the final answer is 6, okay, times each 6s minus 4 plus c. So this is the answer. Okay, so is it right? So you can do more practice on this question about the substitution method. Okay, move to our subtopic. Okay.
So our last subtopic for today is finding equation of the curve from its gradient function. So here we have a given the gradient function dy over dx is equal to f prime s, and the equations of a curve for that function is y equal to integrate f prime s dx.
Okay, guys, this is our last subtopic for today, that is find the equation of a curve from its gradient function. So what is the gradient function actually? So the gradient function is dy over dx, right? We have already learned it from the previous chapter, that is differentiation chapter. So here, read the question.
The gradient function of a curve at point xy is given by dy over dx equals to 15x squared plus 4x minus 3. So what is our gradient function? This one, okay? Alright, so A, if the curve passed through the point, okay, the point -1, 2, find the equation of the curve. The equation of the curve. Okay, when we want to find the equation of curves, what have we do? What should have we do? Integrate. Okay, integrate. So the point here, okay, it's a very important for us. It must be stated because of why? The point here give you a hint that you have to find the C. Find the value of C. Find C. Okay, maybe you are not really imagine. Okay, all right. So B. Subsequently, find the value of y when x equal to 1. Okay, when x equal to 1. Actually, the question of B is actually wants you to find the value of B, the value of y. We substitute the x. Okay, the value of x equal to 1. Okay, here we have the equations of our differentiation in gradient function dy over dx equal to 15x squared plus 4x minus 3. So the equation of the curve, they want the equation of the curve, so we have to integrate. Oh, sorry, before you want to integrate, you have to write the variable y. So here, integrate, just copy it back. So follow the previous subtopic. Okay, we can separate 15x squared dx plus integrate 4x dx plus, oh sorry, not really plus, it's actually minus. Minus. So minus 3. Sorry, it's actually integrate dx. Okay, so integrate 15x squared, we will get 15x cubed over 3 plus, so for x we will get 4x cubed over 2 minus 3, we will get 3x. Don't forget the most important constant, c. Okay, the most important constant, c, you have to write. Okay, so here c, the question is not in the is the best answer because 15 can be divided by 3 and 4 can be divided by 2. So the simplest form, we give the simplest form. So 15 over 3 is 5 x squared plus 4 over 2 is 2x squared minus 3x plus c. So here the value of c, we can find it by substitute the value of x and y using the point given. Using the point given. What is the point given? So we write at point, okay, at point -1 to 2. So sorry, what is our value of y? 2, okay? It's actually as y. Right. So our y is 2. Our s is -1, 2 plus 2, -1 to the power of 2 minus 3, -1 plus c. Okay, so it is actually a cube. Okay, here cube and here is cube. All right. So using your calculator, you will get the value of c, that is c is equal to 2. All right, so the final answer is, I have to write here because there is no space anymore. So just copy it back. So y equal to 5x cubed plus 2x squared minus 3x plus 2. It's a complete answer, the best answer. Okay, so B. Here is our question A. So B. The question asks you to find the value of y by substituting the value of x equal to 1. Okay, so it's very easy. Just substitute in this formula. In this equations, not equation this equation. So what is our y? Oh, the question wants you to find the value of y, and so x equal to 1. So y equal to 5, 1. Okay, y when x equal to 1, right? Substitute. Okay, plus 2. Okay, substitute x minus 3, 1 plus 2. So using your calculator, you will get the answer y equal to 6. That's it. Okay, so that is the final answer. Okay, so I want you to do more exercises in the futures for you to increase your knowledge and be aware of these type of questions. Okay.